warahmatullahi wabarakatuh. Hi, we are from SBP PASU, which is located in Bukit Karitam. My name is Redha.
And I am Shahrul.
And today we are going to present about our project, which is named SMART Incubator 4.0. So why we use 4.0? Because it is for the revolution of 4.0. What's the special about our project? We use a microcontroller named Carrot. So why we use the microcontroller? Because it is the latest innovation of microcontroller that use IoT, which is Internet on the Thing. So we invent this smart incubator in order to help the farmers in our countryside to increase their production in quail eggs and to decrease their work in order to produce the eggs. Before we start using our smart incubator SIF0, we are now going to turn on the switch, and then all the bugs in our smart incubator will be ready to use and hit our incubator. The next step is to check all of our microcontroller manual code. This is the manual code, and now in order to switch on all of component in our smart incubator, we need to turn on the switch in our manual code. When we turn on the switch, the light will be brighten up in order to show that this our manual code is power up. In order to give humidity to all of our eggs, we put a water container under our chamber in smart incubator SIF0. There are also the water level sensor which will detect the water level in the water container, and then all the water will be evaporated and will give the humidity to all the eggs in our eggs holder. The eggs holder can hold up to 30 eggs of eggs quails. We will arrange it side by side, and the humidity will be spread to all the eggs. So when all the humidity has been spread to all the eggs shell will be easily to be hatched, and the quails will be easily to get out of their shells. So that's why we put the water container under this smart incubator to give the humidity to all the eggs in our chamber. So the next component is the water supply and the water pump. The water pump will be connected to the microcontroller manual code Carrot. You need to install the manual code app in your phone, and then all the manual code you need to connect it with this manual code. First, you click the app, and then you will see all the program that have been given to all the consumers. This is all the program, and all the wire will need to be connected to all the sensors in our smart incubator. For example, the water pump, the servo, and the infrared sensors and the ultrasonic sensors that have been connected to the microcontroller. So right now we need to connect to Bluetooth our manual app and with our manual Carrot microcontroller. You click the one, and then say yes, and then it will automatically Bluetooth to our Carrot microcontroller, which is the code that have been given to in our magnetic controller. So just the click that has same numbers, and click OK, and you type the password, and then the app successfully connected to our microcontroller.
As we know, eggs must be physically turned to prevent the developing chick from sticking to the shell. If the embryo stick to the shell, it will die, and the egg must be turned minimum 3 times a day, and 5 times is better. So to save time and to prevent it from sticking to the shell, thus we use the servo. As you can see here, this is how the servo works.
After that, the next component is box that will give warmth in our smart incubator. So right now is the water container and our water level sensor. The water level sensor senses the water in our water container. When all the water has been evaporated, it will send a signal to the microcontroller. The infrared senses the water, and then it will send a signal to the water pump, and the buzzer will be automatically buzzing, and the water pump will pump water and refill the water container back in order to give humidity in our smart incubator. After done refill, the infrared will give a signal. Next component is the fan. The fan is used to give air circulation completely to all our eggs in our smart incubator.
As we all know, the temperature is so important in order to hatch an egg. If too high or too low, the embryo inside the egg will develop abnormally. So what we do? We use the thermostat to set the specific temperature for the quail eggs to hatch, which is 39 degrees Celsius. We have programmed the thermostat and the heat sensor to link together so that when the hatching home reaches above the actual temperature, so the heat sensor will detect it and send the data to the microcontroller. At the same time, the bulb will automatically turn off to maintain the actual temperature for the quail eggs to hatch. For instance, we separated this project into two parts, which is the main part is the hatching home and the second part is the temporary care home. So when the quail hatch is going on into the other parts, so we use the infrared sensor. An infrared sensor is an electronic device that emits in order to sense some aspects of the surroundings. An IR sensor can measure the heat of an object as well as detect the motion. Thus, we can know how much quails that successfully hatched because it will send signal to the magnet code caret and automatically the phone will record a video and email it to its owner. These types of sensor measure only infrared radiation rather than emitting it, that is called a passive
IR sensor.